Have you ever wondered how a transformer works? It's a question that might have crossed your mind, especially considering how integral they are to our daily lives. Transformers are the unsung heroes of our modern world, silently working behind the scenes, powering our homes, schools, and offices. They are the reason we can enjoy the convenience of electricity in our lives. So what exactly is a transformer? Well, in the simplest terms, a transformer is a device that transfers electrical energy from one circuit to another. They do this by using electromagnetic induction, a process that allows them to change the voltage of electricity. This is important because different devices and appliances in our homes and workplaces require different levels of voltage to operate safely and effectively. Now, you might be wondering, why do we need transformers? Well, imagine trying to power your laptop directly from the power plant. Not only would it be impractical, but it would also be incredibly dangerous. Transformers solve this issue by stepping down the high voltage electricity from power plants to a safer, more usable level for our homes and offices. But transformers aren't just about safety. They're also about efficiency. Without transformers, transmitting electricity over long distances would result in significant energy loss. Transformers help mitigate this problem by stepping up the voltage for transmission, reducing energy loss, and then stepping it down again for use. Now, don't worry if you're feeling a bit overwhelmed by all this. The science behind transformers is complex, but it's also fascinating. It involves principles of electromagnetism, electrical engineering, and even a bit of quantum physics. But for now, let's not delve too deeply into these aspects. We'll be exploring them in more detail in the later parts of this video. So, to sum up, transformers are devices that transfer and transform electrical energy, ensuring that we can use electricity safely and efficiently in our everyday lives. They are an integral part of our electrical infrastructure, and without them, our modern world would look very different. Now that we have a basic understanding of what a transformer is, let's delve into the inner workings of this intriguing device. Before we can understand how a transformer works, we need to grasp some basic concepts. Let's start with electricity. Imagine electricity as a river. It flows from one point to another just like water. But unlike a river, electricity needs a conductor like a wire to flow. Now, let's talk about magnetism. You've probably played with magnets in your childhood. You've seen how they can attract or repel each other depending on which poles are facing each other. This is because magnets create a magnetic field around them. So how do electricity and magnetism relate to each other? Well, when electricity flows through a conductor, it creates a magnetic field around it. This is known as electromagnetism. Conversely, a changing magnetic field can induce an electric current in a conductor. This principle is called electromagnetic induction. But how does this apply to transformers? Well, at the heart of a transformer are two coils of wire, the primary coil and the secondary coil, wrapped around a common iron core. When an electric current passes through the primary coil, it creates a magnetic field. This magnetic field then induces an electric current in the secondary coil. This is the basic principle of a transformer. The interesting part is, the voltage of the electricity in the primary coil can be different from the voltage in the secondary coil. This is because the number of turns or loops in each coil can be different. If the secondary coil has more turns than the primary coil, the voltage increases. Conversely, if it has fewer turns, the voltage decreases. This ability to change voltage is what makes transformers so crucial in our electrical systems. With these basics in mind, we can now proceed to understand the intricate workings of a transformer. Ready to explore the inner workings of a transformer? Well, let's jump right in. At its core, a transformer is a simple device with three main components: the primary coil, the secondary coil, and the iron core. You might be thinking, that's it? Just three parts? Absolutely. Sometimes simplicity is key to brilliance. Let's start with the coils. Each coil is essentially a long wire wound around a metallic core. The primary coil is the input side, where we introduce an alternating current. This current generates a magnetic field around the coil. Now, this is where the iron core enters the scene. The iron core serves as a channel, guiding this magnetic field generated by the primary coil to the secondary coil. Without the iron core, the magnetic field would disperse in all directions. By directing the magnetic field, the core ensures that the energy transfer is efficient. And finally, we come to the secondary coil. This coil is similar to the primary one, but it has a different number of windings. The ratio of windings between the primary and secondary coils determines whether the transformer will step up or step down the voltage. If the secondary coil has more windings than the primary, the transformer will step up the voltage. Conversely, if it has fewer windings, it will step down the voltage. Let's imagine the whole process. You plug in your charger into the wall socket. The electricity from the power grid, which is at a very high voltage, enters the primary coil of the transformer in your charger. This creates a magnetic field around the coil. The iron core directs this magnetic field to the secondary coil. If the secondary coil has fewer windings, the voltage is stepped down, and voila, your device is charging safely. But wait, we've been talking about alternating current, right? So the direction of the current changes periodically. This means the direction of the magnetic field also changes. As this changing magnetic field passes through the secondary coil, it induces an alternating voltage. This is known as electromagnetic induction, and it's the principle that transformers operate on. What's incredible about this is that there's no direct electrical connection between the primary and secondary coils. The energy transfer is purely magnetic. This is why transformers are so useful. They allow us to transfer electrical energy without a direct electrical connection and to change the voltage levels efficiently and safely. So that's the magic of a transformer. But why exactly do we need them? We've seen how a transformer works, but why does it matter? Let's dive into the world of transformers to answer this question. Transformers are the unsung heroes of our electrified lives. They play a critical role in the transmission and distribution of electricity. But how does this happen? Well, transformers are key in stepping up or stepping down voltage levels. When electricity is generated at a power station, it is at a relatively low voltage. To transport this electricity over long distances to our homes and businesses, the voltage needs to be stepped up to reduce energy loss during transmission. Once it reaches its destination, it must be stepped down again for safe use in our homes. This stepping up and stepping down of voltage is performed by transformers, making them critical for efficient and safe distribution of electricity. But transformers aren't just nestled away in power stations or hidden on power poles. They're also a part of our everyday lives, and you'll find them in a multitude of appliances around your home. Ever wondered how your cell phone charger manages to safely charge your phone without frying its circuits? It's all thanks to a small transformer within the charger that steps down the voltage from the power outlet to a level that your phone can safely handle. Similarly, your microwave, television, and even your electric toothbrush all rely on transformers. They ensure these devices receive the right voltage to operate safely and effectively. In the world of electronics, transformers serve as a bridge, enabling devices of different voltage requirements to work together harmoniously. They provide the flexibility to design and use electronic devices without having to worry about matching the power supply voltage. In conclusion, transformers are indispensable in our electrified world. They ensure the smooth operation of power grids and the safe use of electricity in our homes and businesses. From stepping up and down voltages to enabling the functioning of everyday appliances, transformers truly play a pivotal role in our lives. From the power lines to your cell phone charger, transformers play a pivotal role in our lives. Let's take a moment to recap what we've learned today. We started our journey with a basic introduction to transformers, those ingenious devices that play a crucial role in the smooth transmission of electricity. We then dove deeper into the nuts and bolts of how they function, exploring the fascinating world of magnetic fields, coils, and voltage. We discovered how transformers utilize the principles of electromagnetic induction to step up or step down voltage, ensuring that the power reaching our homes is safe and usable. We also highlighted the wide array of applications where transformers are indispensable, from the giant substations that power entire cities to the tiny ones inside your mobile phone charger. These extraordinary devices are woven into the very fabric of our daily lives, silently and efficiently keeping our world electrified. So the next time you plug in your device, remember the sophisticated science powering it. The